Hello, everyone. My name is Lindsay Shuck. Thank you for joining the Family Office Network's webinar series today featuring EPS Holdings, the future of power generation. I would like to introduce our speaker today, Michael Daly, President and CEO. Michael has an extensive senior management experience within the financial institute sector. He has been an imperative part of the senior management team during EPS's development phase and is looking to move the company into commercialization. At the end of today's presentation, we will have time for Q&A. We encourage you to submit your questions using the questions drop-down option on your screen at any point during this webinar.
Thanks, Lindsay. Good afternoon, everyone. As Lindsay introduced me, my name is Michael Daly, and I'm President and CEO of EPS Holdings. First of all, I would like to thank you for sharing your time with me today to learn about an exciting new venture that we believe will make significant inroads in the distributed energy and renewable energy space. In my presentation, I'll be going through the PowerPoint presentation you have access to and hopefully is up on your screens now. We have time allocated for questions and answers at the end of the session, but if you have additional questions, I would be keen to speak with you on a one-on-one basis over the next few days. Before we begin, I would like to thank Lindsay Shuck and Audra Plageman and their team at Family Office Networks for assisting me with this presentation and providing me an opportunity to speak with all of you today. We have a very powerful corporate objective to become the preeminent leader in distributed energy generation through advanced turbine engine technology development over the next 6 years. I would like to go through how EPS intends to accomplish that objective. I think a crucial question is why EPS exists and how do we get to where we are today. Although I will not be reading directly from the slide deck today, I think it is important for me to highlight each of the bullet points on this slide. EPS believes the distributed energy sector, or also known as DE, will be one of the fastest growing sectors in the market for many years to come. DE is where the end power users effectively go off the grid to produce their own electricity independent of larger central power stations. DE is currently dominated by noisy and bulky, high emission producing and costly to operate and maintain diesel engines, or reciprocating engines, or recips as they were referred to. And those engines, those recips, are currently our major competition. EPS believes a very viable solution to service the DE market is through the production of small scale turbine engines that are cost competitive, highly efficient, easily transportable while incurring lower operational and maintenance costs and producing fewer emissions than its competitors. We believe the small scale 1 to 5 megawatt size turbine engine sector has been significantly underserviced by large scale turbine manufacturers such as Siemens and GE, who are only focused on manufacturing larger frame machines. Generally, larger scale turbines in excess of 50 megawatts are highly efficient, while small scale turbines are significantly less efficient. What this all means and leads up to is a game-changing premise that EPS has found an enabling technology to capture the high efficiencies found in large-scale turbines and incorporated that technology into its small-scale turbines through a patented process. So to be clear, we are not wind power, we're not solar power. Our sole focus is on manufacturing small-scale turbines to produce primary power, not backup power, using a variety of fuel sources for use in the distributed energy sector. First, a summary of what our plans are and where we are today. I would like to go through what we would want in our engines. We would want to have the best-in-class efficiency, have the lowest operating and maintenance costs, the lowest emissions, the longest operating life, and have the best system uptime availability. We're going to focus on manufacturing turbines in the 1 to 5 megawatt power range scale. This is considered small scale. Some would even say these are micro turbines. Initially, we will have 2 turbine engines. One will be a 1.6 megawatt multi-fuel turbine that will use any form of liquid or gaseous fuel as its power source. And the other will be a 1.2 megawatt biomass turbine that will run on any form of solid waste biomass. The key is that our engines will compete very favorably against the diesel engines that currently dominate this engine space. EPS engines will provide primary power for many end user groups using abundance of fuel sources. We have about 8 years in development already under our belt. We raised and fully deployed $6 million US in cash equity we received from about 35 shareholders, mostly friends and family in this initial development stage. The enabling technology has been secured through a 20-year royalty-free license arrangement with our design and engineering partner, Brayton Energy, but more on them later. We built and successfully tested a quarter-scale model of the biomass combustion chamber. We have 2 customers that have signed letters of intent to purchase significant quantities of our turbines. We anticipate that we will be ready for full-scale commercial production in approximately 2.5 years after the alpha and beta stage testing is complete. What EPS is looking for right now is $18 million US over the next 10 quarters to complete the development stage and move forward towards full-scale production, but more on that later. From a financial aspect, our first production engines are scheduled to be shipped in Q4 2022. Although I will go into more financial information a little later on in the presentation, we anticipate receiving our progress payments in advance of our first commercial orders. The first such payments are expected to be received in Q3 2022. The sale price of our 1.6 megawatt multi-fuel turbine is $1,440,000, and the sale price for the EPS 1.2 megawatt biomass turbine is $1.8 million US. Our financial model is indicating that our gross margins will be running about 37 to 38% at full production volumes, with ROEs exceeding 90% by year 5. The key point is that we have customers waiting to purchase our turbines. This is an architect's rendering of our 1.6 megawatt multi-fuel unit without the enclosure cover. Now let's talk about this engine in a little more detail. This turbine can run on more types of fuel than just natural gas. It can run on any form of gaseous or liquid fuel. Besides natural gas, some fuel sources that could be used include propane, methane gas, high sulfur sour gas, synthetic gas, and biodiesel. To give some reference, just one 1.6 megawatt turbine unit made by EPS will produce enough energy to power 500 to 700 homes, a small college or educational facility, a small hotel, a small to medium-sized office complex, a hospital, or a clinic. For the techies in the audience today, the net electric efficiency is 40.6% at full base load capacity, or for those who prefer to hear our efficiency stated as a heat rate, it is 8,405 BTUs per hour per megawatt. With natural gas at or near its lowest price in decades, combined with an integrated delivery system in most developed countries, natural gas fuel EPS turbines makes perfect sense today for end users who want to get off the grid quickly. The multi-fuel turbine can also be used as a peaker unit to provide additional backup power for larger corporate or industrial users, or for small utility companies who need additional power availability to provide customers primary power during peak hour periods. Now let's flip to our biomass unit. Again, here's an architect's rendering of our 1.2 megawatt biomass unit without the enclosure cover. An important aspect of both our 1.6 megawatt fuel and the 1.2 biomass turbine is that there is large commonality of parts between the 2 turbines. So we are using the same core engine design for both turbines. This is a huge production advantage for EPS. Another key production and selling feature is that both engines can be scaled up to 5 megawatts of power, and if required by a customer with larger power demands, They can be put in series to form a 20 megawatt power substation. That is a lot of power to potentially get off the grid. Firstly, it should be noted that to our understanding, there is no other biomass turbine that exists today in the 1 to 5 megawatt size range. That's what makes EPS unique and gives us a competitive advantage when providing power to the distributed energy sector using turbine engines, is our biomass capabilities. Our biomass engine fulfills the growing world demand for affordable, sustainable, and renewable energy. We can run on many forms of biomass fuel, including wood chips, wood pellets, sawdust, animal waste, bagasse, which is sugarcane extracts, commercial and agricultural waste, algae, and landfill trash, to name a few. Most likely, our biomass units will be placed at where the fuel source is located or where the power is needed. For those of you familiar with gasification systems, our biomass unit does not gasify the waste. So we avoid the costly process of heating, then cleaning the solid waste biomass into a liquid, then using this liquid to produce power. Our process is called thermal extraction or thermal conversion, where we burn directly the biomass at very high temperatures of approximately 1,000 degrees Celsius or 1,800 degrees Fahrenheit. Potential customers have told us this thermal conversion process is a real game changer. There are three main advantages of EPS turbines over conventional-based diesel engines. First is that you want to have a high efficiency rating, which translates into lower fuel costs. Our multi-fuel turbine has a 40.6 efficiency. No other turbine engine comes close to that number in this power range. For those who are familiar with combined heat and power, or CHP applications, our efficiencies could reach 85% to 90% when we transfer the heated ambient air into common areas, such as heating swimming pools and providing indoor heating to shopping malls or universities, or any structure with large open or common spaces. Second, because of its very nature, turbine engines have many fewer moving parts versus reciprocating engines. So our operating and maintenance costs are approximately 1/3 what comparable recips would have. That is a huge cost saving for EPS. Thirdly, a very important consideration today is that EPS turbines have almost negligible nitric oxide emissions, as well as extremely low CO and CO2 emissions. This factor is very key to potential buyers and users of our turbines who are conscious of the environment. EPS turbines are designed to operate with minimum intervention and cost. When I mentioned that EPS turbines have lower operating and maintenance costs, one of the main reasons is that the initial life of the engine before remanufacturing is 60,000 hours, or about 6.8 years if that engine is running 24/7. That is a significant lifespan of any engine and a big benefit when considering to purchase a turbine engine over a diesel engine. In summary, there has been considerable interest when evaluating the benefits of an EPS turbine versus another small-scale turbine or a reciprocating engine. To summarize again, these benefits include that EPS engines are available in either liquid or a gaseous version or a biomass version with strong commonality of parts. No other biomass turbine exists. We have very low emissions that will meet or exceed North American and EU emission standards. They're scalable up to 5 megawatts, and we received interest for a 3 megawatt version as well. They can be put in series to form a 20 megawatt power substation. They are lightweight and carry a small footprint. For delivery to a customer's location, they can be put on the back of a flatbed truck or a standard 20-foot shipping container. One of the areas that EPS is very committed to is to ensure that EPS turbines have a worldwide reach, even in developing or underdeveloped nations. We believe that everyone should have the right to clean, reliable power at affordable prices. We have had discussions with the government of Senegal and other African nations and believe that it would be wonderful if EPS can participate in powering Africa to provide enough energy for villages to have clean drinking water through water purification facilities, power to run a school, power to run a hospital or clinic, and provide the internet to villages to stay in touch with the world around them. I would like to outline the benefits of investing in EPS and why your family office might consider an investment in our company. Green energy investments are increasingly seen as attractive in private and institutional portfolios. In a few years' time, we believe EPS will be ripe for a takeover bid or as an early IPO candidate. We have three strong reasons for you to consider an investment in EPS. Firstly, we have powerful economics to make an investment attractive. We have prepared a detailed 7-year financial projection. This forecast was based on input from our letters of intent potential customers, plus early market indications, which show an attractive sales growth leading to attractive gross margins and high ROI projections. Secondly, we are striving for technological superiority with our turbines. We have partnered with Brayton Energy, a design and engineering firm based in Hampton, New Hampshire. Brayton have a deep understanding of the turbine industry, especially the gas turbine industry. Quite simply, our biomass turbine is a game changer. Nobody else is doing it at this power range. No other turbine compares with the efficiencies achieved from our multi-fuel turbine. Thirdly, EPS is in a high growth market. Renewable energy through distributed generation is one of the fastest growing industry sectors. We have LOIs signed by 2 customers waiting to purchase quantities of our turbines. As mentioned previously, EPS is seeking $18 million, and when I should also say that any dollar figures I quote today will all be in US dollars, to complete its development and ramp up to begin commercialization and production. This $18 million can be received in one lump sum, or can be also received in a series of tranches over 10 quarters to coincide with predetermined milestones during the final development period. The $18 million can be received from one or multiple investors. EPS is offering a 45% common share equity interest in EPS for an $18 million cash investment. Although we prefer common share equity, we will consider issuing preferred shares or senior debt. Of the $18 million investment, $12 million will be used to build the full-scale alpha unit, and that will be housed at Brayton's facilities in Hampton, New Hampshire, and to build 2 beta units. One will be a full-size multi-scale or multi-fuel unit, and the other will be a full-scale biomass beta unit that will be housed and continually tested at customer locations. Currently in the financial forecast, we have assumed an in-house build-out of our assembly plant operations. In the first 12 to 15 months of this development stage, EPS will make a determination if we want to continue down the path of building out that assembly operations in-house or outsource the assembly function to a third party who will assemble the EPS turbines at their facilities. Part of the capital remaining from this raise will go towards the gearing up of the assembly operation, hiring a sales and marketing force, and incurring general office expenses. A detailed analysis of this use of funds document is included in with our 7-year financial projection analysis. Outlined on this slide is a summary of those costs and the period in which they are expected to be incurred. As you can see, the alpha and beta unit build-outs comprise the lion's share of the costs during this period. We have also forecasted costs associated with an in-house assembly plant, including initial inventory purchases, capital expenditures, and other assembly plant costs. At this time, it is not anticipated that additional capital funds will be required beyond this 2.5-year development period due to the upfront payments or progress payments received from the sale of commercial units. EPS will be a self-funding operation. I've included a list of the major milestones that we expect to achieve over the 2.5-year development period. I will not go into this in full detail, but you can see we believe these milestones are achievable and realistic. Please note that the full-scale alpha unit will be completed and tested, about 30% tested after 4 quarters of development. The first commercial unit is expected to commence production in Q4 2022 or in the 10th quarter of the development period. I have outlined some of the pertinent financial information from the 7-year detailed financial projections package in the slide. Gross sales are expected to ramp up quite quickly after the development period. It is planned that we will be running at 2 shifts per day by year 5. Gross sales in year 7 are projected to be in excess of 1.3 billion. At the end of year 7, assets are projected to be in excess of 770 million, with total shareholders' equity projected to be in excess of 570 million. ROI projections continually increase until year 6, when we projected to start paying dividends of 20% of after-tax net income. The number of units assembled each day is continually rising throughout our entire projection period. If you look at the very last line, you'll see the average of units projected per day. We're looking at producing approximately 2.7 units per day in year 6. We anticipate at this time that we'll have multiple worldwide locations performing the assembly operations. Although we have touched on some of these points already, I want to reinforce a few of the marketing efforts again here. The worldwide distributed energy sector was worth approximately $163 billion in 2016, and now it's expected to grow to $573 billion by 2025. That is huge. EPS has the ability to transform the under 20 megawatt DE sector from diesel-based engines to very efficient EPS turbines. EPS will first concentrate on the US and European market, but we've already had discussions with Brazilian, Korean, and African officials about using EPS turbines, as well as officials from various Scandinavian countries. Our business model, but not including in our financial projections, includes selling energy through purchase power agreements, or PPAs, as some of you might know. A huge potential opportunity for EPS could be to own our US turbine engines outright and provide and sell the power produced directly to small or medium-sized villages. In this case, EPS would sell power, not a turbine engine. We would try out this concept first in the United States or Canada. I've outlined the various markets and potential end users for EPS turbines. The opportunities are plentiful and limited to only how one thinks what markets could be converted to distributed energy applications. EPS has high opportunities in the commercial sector through big box retail stores, shopping malls, and hotels. In the industrial sector, potential EPS targets include utility and power producers, as well as manufacturing facilities. We also see growth opportunity in apartment complexes and housing developments, as well as universities and schools. As mentioned, EPS would be participating in the in the under 5 megawatt power range for the DE sector. In that range, our main competitors right now is from reciprocating or diesel engines, whose manufacturers include, and you might have heard of these suppliers, Caterpillar, Yanbacher, Cummins, Wärtsilä, and Waukesha. To a lesser degree, we see competition from other small-scale turbine engine producers, including Capstone, Dresser-Rand, Kawasaki, Oprah, and Solar. Here's a competitive assessment table comparing various characteristics of the EPS turbine against small-scale turbines and reciprocating engines. The 3 characteristics I would like to focus on here is, in the second row down, you'll see efficiency at 100% full load, and you'll see EPS, the first column there, at 40.6%. And then the next 2 columns, you'll see 2 other turbine engines. They're at 24.5% and 22%. So we're significantly above those. And then the recips are somewhat lower than us as well at 37 and 35%. Those are the last two columns. If you look 5 rows down, you'll see the service costs per kilowatt hour. The EPS turbine is 0.8 of a cent per kilowatt hour. And the next 2 turbines are 1.5 cents per kilowatt hour. And then the 2 recips on the far right are 2.5 cents per kilowatt hour. So to reiterate, the EPS O&M costs are only 1/3 what the O&M costs would be for the recips. 10 rows down, you'll see various emission characteristics. The 10th row has actually the NOx output in grams per hour per megawatt. The EPS turbine produces only 8 grams per megawatt per hour. Another turbine is 660 grams, yet another turbine is 750 grams. Well, the 2 recip engines are at 2,822 grams and 30,661 grams. That's a huge difference, and it's a difference that we believe we can capitalize on at EPS. Right now, EPS is working very closely with its technical partner, Brayton Energy, located in Hampton, New Hampshire. They have a very good website there at the end of that slide that you might want to take a look at. But they're a design and engineering shop that have about 36 engineers as part of their 45 staff count. To be clear, Brayton has no equity ownership in EPS, and they are paid by EPS, or have been paid, to build out the quarter-scale biomass combustor chamber and perform all the development work on our turbine design engine to meet EPS specifications. Brayton's key role in going forward to build out our full-scale alpha unit and the 2 beta units. In addition, Brayton will provide ongoing technical support and sustained engineering once EPS goes into its commercialization stage. EPS enabling technology is the patents owned by principals of Brayton on the intercooled recuperated system, which EPS has secured under a 20-year royalty-free license arrangement. I am in constant contact with Jim Kessley, the CEO of Brayton. Jim is a big supporter of the EPS project and remains a special consultant to the EPS board. Now we're going to look at some of the 2 letters of intent we received. One is from a company called PowerSecure, and it's in North Carolina in Wake Forest. PowerSecure is a subsidiary of Southern Corporation and a leading provider of innovative energy solutions to electric utilities and their industrial, institutional, and commercial customers. PowerSecure provides energy solutions in the distributed generation sector that EPS is focusing on. The company is a pioneer in developing distributed power systems and the integration of distributed energy resources. I've met several times with key senior officers, including their CEO. They have signed a letter of intent to buy significant quantities of both the multi-fuel and biomass versions of the EPS turbines. They are focused on our multi-fuel unit and want to use 70% of the units they purchase as peaker units to replace their aging recip engines. The second letter of intent is from a company called O2E out of the UK, but their focus is on continental Europe. O2E is, they produce synthetic fuels from plastic and organic waste materials. The CEO really likes our biomass unit and wants to buy 300 to 500 megawatts of power capabilities from our biomass turbines in the years to come. They will allow us to install a beta prototype at their new R&D site. They would also like to assist us in installing that beta unit at their, as I said, in their R&D center. Here's a picture of our multi-fuel unit. Not much to look at, but the key here is that it is only 7 feet high by 8 feet wide by 15 feet long, a very compact piece of machinery. Again, I don't want to get into much detail here on the overview schematic drawing of the 1.2 megawatt biomass turbine, but just to let you know, it has a 2-stage compressor compressor section along with a 2-stage turbine section. The dotted line shows the commonality of parts between the multi-fuel and the biomass turbines. The biomass unit has a larger recuperator, which is the heat exchanger on the right side of the diagram, than the multi-fuel turbine. Another interesting fact you see is that the reference to the baghouse for the ash removal. The EPS biomass turbine produces only 60 pounds of ash as waste from every ton of biomass fuel it uses. This equates to only a 3% waste percentage. Although it might look like somebody's backyard wood still, here is the 1/4 scale biomass combustion chamber as assembled and tested at Brayton's New Hampshire facility. It was fired up using both sawdust and kelp. The key is that the data collected from the emissions monitor showed a very clean burn and confirmed that emissions particulates were within California government standards. The EPS board is currently comprised of 3 members, myself, Paul Benefides, and Catherine Kelly. All of us are personally invested in EPS and have a long history with the company. Our bios are attached on the following this slide, as well as the slide on the next page. I don't need to go over them in detail. You can do so, but you can contact any of us. To date, we haven't hired any full-time employees. We didn't want to hire a full staff before we had capital commitments secured, so we've been running a pretty lean shop. I have not been taking any money for the work that I have been doing, but rather have been taking my compensation in common and preferred shares. EPS's progress to date has been made possible by the joint cooperation of 4 main parties. First, my fellow board members, Paul and Katie, who are with us today. Secondly, Jim Kesley, the CEO of Brayton and his engineering team at Brayton Energy. Third, I have a good group of former board members and senior shareholders at EPS. And lastly, 3 other special consultants to the EPS board, Doug Anderson, Steve Griller, and John O'Rourke, who I lean on for market and technical guidance and assistance with the capital and also with the capital raise component of EPS. All of these special consultants to the EPS board have extensive backgrounds in the turbine engine and energy fields. And Steve's and John's. Well, finally, I hope that I've imparted some knowledge on the distributed energy sector and how EPS is ready and able to become a big part of it through its advanced turbine engine technology. I'd hope that you would consider learning more about EPS and how this could be a very exciting investment opportunity for your family office. I can be reached at the above email address and phone number. Please do not hesitate to contact me if you have questions. Thank you for your time today. I really appreciate it. I will turn the session back over to Lindsay, who will monitor the question and answer section. Lindsay?
Thank you, Michael. I appreciate that. Again, I want to take a moment to encourage everyone to send over questions if they have any using the questions drop-down option on your screen. I will go ahead and get started. We do have a question asking where the IP license is coming from.
The IP license is coming from Brayton Energy, who holds up to 19 patents related with the intercooled recuperated section of the turbine. So Brayton and its principals hold the patents, and we have a royalty-free license arrangement with them for 20 years.
Okay, perfect. And cost comparison versus wind and solar. Can you kind of elaborate on that a little bit?
Yes, to some degree. We believe that our turbines are much more cost effective when the full cost of the fuel source is included. Wind and solar power still rely a lot on government grants and subsidies. We do not, and we would be happy to share some costing offline on this, but our costs, when all is considered, is much better and we will be selling our units for initially about $900 per kilowatt, and for the multi-fuel, and $1,500 per kilowatt for our biomass unit, which is significantly less than the upfront capital required for a solar or wind power station.
Okay, perfect. Actually, Robert does have another question. He says, what is the evaluation of this round?
The valuation of this round would be that we would be selling shares at about $1.30 a share, and our valuation based on a discounted cash flow model is $21.60 per share.
Okay, perfect. Peter asks, any particular reason for the Bermuda address?
Yes, and this is also related to the IP question at the first. We have, the company is registered right now as a Bermuda company. That is where the holding company is, EPS Holdings. We haven't incorporated any other subsidiaries, but we will be incorporating those subsidiaries when they arise over the next 2 to 3 years. We expect to have a subsidiary in Canada, in the US, probably in Brazil, and also in a Scandinavian country. The idea is that we would like to house the IP in Bermuda, and then have those subsidiaries pay a royalty payment up to Bermuda, which would go on a tax-free basis. So it's an efficient way of housing the IP and separating it off from the various subsidiaries that EPS might hold in the future. There's other tax advantages also to be in Bermuda, and we can go over those at a later time.
Okay, great. Thanks, Mike. Can you tell us a little bit about some obstacles that you've faced raising capital to date?
I think one of the biggest obstacles we've had is that although we've raised $6 million and have and that's cash in the form of common and preferred shares, we're a pre-revenue company, and there's no way to get around that. And some investors just say, I don't want to invest until there's revenue. It's too early for me to invest. It's a sector I'm not familiar with. Another obstacle is that we don't have a full-scale working model. We have a very valuable team in Brayton who made a lot of turbine engines in the past, but we have, we don't have one fully up and running at full scale. And the pre-revenue and we don't have a full-scale working model has proven to be a larger obstacle than we initially thought.
Great, thank you. And actually, Robert wrote back in, and he was wanting to understand a little bit, or he did not understand that when you were commenting on the IP source, if you can maybe repeat that answer again.
Okay. The IP right now is held at Brayton Energy, or sorry, at Brayton Energy. The patents are through principals at Brayton. EPS has a draft agreement to an arrangement to have a royalty-free arrangement for 20 years to use those patents in our turbines. The enabling technology that I referred to was on the intercooled recuperated engine. That's our secret sauce. That's what sets us apart. That's what makes EPS unique. So that IP will be licensed to us via that agreement with Brayton Energy.
Okay, great, thank you. What production alternatives have you investigated to assemble these engines?
Well, I think it's a good question. It is one that we've been wrestling with for a while. We right now in the financial projection model, we have incorporated costs that we would build out our assembly facility in-house. I think one thing to say before I go further is that we will not be manufacturing anything ourselves at EPS. We're going to be an assembly operation. The parts that we have, the turbine engine parts, will all be custom made, and they'll be supplied to us from various suppliers, and we'll be assembling the turbines, not manufacturing them from scratch. So the idea is, do we manufacture in-house or do we outsource this? The outsourced company we've talked to quite extensively is Jabil out of St. Petersburg, Florida. I know there's other ones out there as well. And we haven't finalized if we're going to outsource or through Jabil or some other entity or build within. And we'd have to look at the cost comparison of those.
Okay, great, thank you. Let's see, any planned deck map for your growth proposal?
Could you please repeat that question?
Yeah, I'm not sure it was sent over appropriately. Any planned deck for your map growth proposal?
Map growth proposal. I'm not sure what the map growth proposal is, but the idea is we're trying to raise $18 million.
I think he's asking about your growth plan.
The growth plan as far as units that we're contemplating building or projected to build? I'm not sure.
I think as far as like what financially.
Well, I think one thing to consider, and maybe I didn't stress this enough, is that as I mentioned, EPS it's anticipated that we will be self-funding our units, and that we don't need separate debt or any other capital to finance our growth. In other words, we're looking at a schedule where we would get 30% of the upfront sales price of the turbine on order, another 30% when we start to produce it, another 30%. So we've got 60% of the sales price in our pocket before we commence production with the two first 30% amounts, then 30% when it's completed, and then the final 10% when it's shipped. So we're looking to self-fund through our vendors that would be, I was not say vendors, customers who would be buying our machines. So we don't anticipate a lot of debt.
Perfect, thank you. Let's see, are the data presented from the real 1/4 size model for both multi-fuel and also biomass?
Could you repeat the beginning of that question again? Sorry.
That's okay. It just says, are the data presented? So maybe he's asking, is the data presented from the real 1/4 size model for both multi-fuel and also on biomass?
Oh, okay. The quarter scale model was only on the biomass combustion chamber. Okay. We were effectively building that chamber to verify the emissions and the clean burn and the efficiencies of the clean burn. The data presented on the overall characteristics are modeled through Brayton and do not correspond to the quarter scale model. That was a separate build. So what we've done is we've looked at, or Brayton has fulfilled the the analysis of the looking at the output characteristics through their own modeling.
Perfect, thank you. We have a question from Rex Danford. What is EPS's pre-money valuation? What proportion of the fully diluted shares of EPS will the 18 million offering shareholder hold?
They will get 45% of the shares after the 18 million is invested. So the total value after their 18 million investment is they would hold 45% and the existing shareholders would drop down to 55%.
Okay, fantastic. For now, Mike, that seems to be all the questions that have come in. If there's anything else you would like to add, please do so now.
Oh, that I would like to add?
Is anything else? Yep.
The only thing I'd like to say is that we believe that EPS is in the right place at the right time for to make a very important impact in the distributed energy sector. We have the technology. We have a great team in Brayton. We have customers waiting, and we have a very affordable high power machine that we think has a lot of end users, and we're very excited by it. Our customers are excited by it, and we think it has a fantastic financial opportunities for potential shareholders.
Great. And actually, we did have a couple more questions kind of trickle in, and Rex is following up on his question about the shareholding. He asks again, does 55% include dilution from options?
There'll be no options granted. So in other words, just say there's no, sorry, Rex, there's no options outstanding right now. So the only thing is that is a fully diluted 45% ownership.
Perfect, thank you. And another question came in. How do you get the 40% efficiency on multi-fuel? Is that on simulation?
Yes, it's on through Brayton's simulations of the turbine engines that they've already produced and modeled to the EPS specifications. So Brayton has a very powerful and comprehensive analysis what they've done, and they would welcome, along with I would welcome any potential investor to join me up at Brayton's facilities in New Hampshire to go over all their calculations of how they have calculated that.
Okay, well, that seems to be all the questions. Again, we wanted to thank everyone for attending this webinar today. Michael Daly, President and CEO of EPS Holdings. Michael and myself will be in touch with everyone directly after this webinar to follow up, but please don't hesitate to reach out if you guys have any questions. And we look forward to speaking with you in the future.
Thank you very much, Lindsay. Thank you, everyone, for your time today.
Have a great day. Thank you.